Hello, calculus fans. All right, let's try to find all the critical numbers of this function, f of x equals cube root of x squared times 2x minus 1. And let's try to recall the definition of what a critical number is. It's a number that's in the domain of f of x where the derivative either doesn't exist or is equal to 0. We'll need to take a derivative to see where this happens. The first thing we'll do is rewrite the function so that we can get rid of the radical. So this cube root of x squared will turn into x to the 2/3. And then if we distribute, we'll get f of x equals 2x to the 5/3 minus x to the 2/3. Now double check the algebra. Make sure that you really believe that this is what we get in simplifying this expression. Don't just take my word for it. So now we're going to take a derivative. So up to this point, it was just a little bit of algebraic manipulation. So if we take a derivative, we're going to get f prime of x equals 10/3 x to the 2/3 minus 2/3 x to the minus 1/3. So this is just using the power rule to go from here to here. Make sure you double check that calculation also. Now I'd like to do a little more algebraic simplification, this time with the derivative. Let's take this negative power that we see here and move it into the denominator. So we'll do a little bit of moving around now. So that x to the minus 1/3 got moved into the denominator to turn into a x to the positive 1/3, trying to get rid of the negative exponent. And then this x to the 2/3 here, I'll just move it up with the 10 in the numerator, since it's already a positive exponent. Okay, so our next step is to try to make a common denominator. So we'll multiply the first fraction, we'll multiply the top and the bottom by x to the 1/3. And so we get this expression. And now that we have the common denominators, we can combine these into a single fraction. Should look something like this. Now, let's remember what we're trying to figure out here. We want to know what are the critical numbers. So, the critical number is a number in the domain of the original function where the derivative either doesn't exist or is equal to 0. So you should be able to see that the derivative doesn't exist when x is equal to 0. And x is equal to 0 is in the domain of the original function. Remember that in order to be a critical number, the number has to be in the domain of the original function. Okay, so the derivative doesn't exist when x equals 0. That's in the domain of the original function. So that's going to be one of our critical numbers. And then the derivative is equal to 0 when 2x minus 2 is equal to 0. And that happens when x is equal to 1/5. So that's also a critical number. And those are the only points where the derivative either doesn't exist or is equal to 0. So those are the only two critical numbers. Okay, that's all for now.